Hello everyone, good evening. I'm back here with a connective video of the linear regression that is about the residuals. As you see that the linear line fit, it has dots around. You will always get a doubt. Once we fix the linear regression line, what are we going to talk about these dots and what they are called as? That's what we are going to learn today. And you know very well, you have to share this video, like the video, and also ensure that you will share with someone who are really interested to learn analytics. Let's jump into the lesson without further delay. Let's go and learn residuals today. The line never perfectly hits the data points. In linear regression, we draw a line of best fit to predict outcomes, but let's be honest, that line is rarely perfect. It misses almost every single data point. The distance between where we predicted our point to be and where it actually landed, that gap is called a residual. And understanding those gaps is the secret of knowing if your model is actually any good. Why to keep them watching? Why should you care about these gaps? Because residuals are not just errors, they are the key to unlocking your model's health. By analyzing the pattern of these residuals, we can diagnose if our model is biased, if we need more features, or if we are ready to trust our predictions. So, how about when you look at a plot with a clear or a U shape in your residual plot? Your model is failing. A pattern like this indicates that your data has non-linear relationship, like a curve, that your straight line regression simply cannot account for. You likely need to use a different model, such as polynomial regression. Sometimes the residual starts small and get wider as you move across the x-axis, creating a funnel or a cone shape. This is called heteroscedasticity. It means the spread of your error is not consistent. Your model is very accurate in some areas of the data but becomes increasingly unreliable in others. This often requires data transformation, like taking log of your dependent variable to fix it. So, how about when you look at the pattern and it is just looking like a random scatter? If your plot looks like a random cloud of points centered around 0 with no distinct shape, your model is great. It means your linear regression has captured all the patterns in the data and the remaining errors are just random noise. So, to compute this residual, how do we get into it? Residual is nothing but the difference between observed value and predicted value. How do we predict a positive residual? We interpreted a positive residual as the actual value was higher than predicted, then the model is underestimated. For a negative residual, the actual value was lower than the predicted, the model is overestimated. So, this is the story of the residual, which has to be considered not just the line of it. The residual and the shape of the residuals really matter to understand the best model that we are predicting. Thank you. Stay tuned. I'm going to join you back with another interesting video related to linear regression soon. Thank you.